Hey guys, it's Micah with the Modern Einstein. Today I'm going to be doing a tech segment about binary numbers. And because the reason this is a tech segment is some of you may know and some of you may not, but your computer's processor processes things and it executes commands, and it does this by reading binary numbers. So if I were to create a program in, let's say, Java, I was writing a program. In Java, what you do is you have a language that you follow, and you type that language, and then you compile it. When you compile your project or compile your file, what it does is translate the program language into language that the computer can understand, which is binary. So every time you execute a file, or every time you open a icon on your desktop, it sends program in binary to your processor. So every time your processor does something, it's reading it in binary. And today I'm going to be teaching you how to convert binary numbers to decimal numbers, which is what we use. And for those of you who don't know, a binary number system is a base 2 number system. It consists of two numbers, 1 and 0. Whereas the decimal system, which is what we use, is a base 10 system. It's 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I forgot 0 through 9. So what I'm going to teach you to do is I'm going to teach you how to convert a decimal or a binary to a decimal, and I'm going to teach you how to count. But first, to do this, I need to take you back to your elementary years and teach you about place values. Not really teach you, because you already know this, but the only reason I'm doing this is so that we can compare it to binary number systems, and we can see how the only thing that changes in converting is the place value. So let's take a look over here. We all know this number. It's 1,568. And we can also write it like this, underneath the place values. We have a ones place, a tens place, hundreds place, and thousands place. We all know this. It increases, our place values increase exponentially by 10 because it's a base 10 system. And we all know as well that it doesn't just stop at 1,000. It could keep going to ones, tens, 100,000s, 10,000s, 100,000s, and so on. I just stopped here for demonstration purposes. Same with your binary number system. It's infinite as well. So knowing what we know here, how we can write it underneath the place value, we could say that this is a 1. We have 1 in the 1,000th place. So this number could also be written as this, 1,000. We have 5 100s, 6 10s, which is 60, and 8 1s, which is 8. So this number, 1,568, can be written like this. So if we didn't know how to write numbers in the binaries and the decimal system like we did now, we could know the place values and then write the number out and convert it like this. And this is the same number, 1,568. The same exact principle applies when we're converting binary numbers. All we need to know to convert it is the decimal or the place values. And the only thing that changes from binary or from decimal to binary is the place values. And binary, there's 2, base 2, and in decimal there's base 10. As we know, in decimal it's like I said, 0 through 9. In binary, it's 0 and 1. So, keeping in mind how we can write out our place values, write the number underneath it, and break it down like this, and add them all up, let's keep that in mind and do the same thing with the binary number system. So the only thing that changes would be the place values. They increase exponentially by 10. So it would be a 1's place, a 2's place, 4's place, an 8's place, 16, a 32, 64, and a 128. And likewise with the binary system, we know it doesn't just end here. I'm just drawing out for demonstration purposes 8. This could also keep increasing after 128. It could keep going because numbers are infinite. However, if you notice, there's 8 place values here. 1, 2, 3, 4, 5, 6, 7, 8. In a binary system, this would be called an 8-bit system. Now you might have heard of a 64-bit computer system. So what this means is it's able to process numbers with more place values, which means it's a bigger number. So if I were to draw these place values out 64 times, it would be 64-bit. So if you have a higher bit system, you can process more. You can process bigger numbers, so your computer can communicate to itself better. So keeping in mind the same principle, let's just make up a binary number. Let's remember, keeping in mind it's only ones and zeros. Let's just whatever comes to my head. 1 0 0 1 1 1 0 1. We've done the same thing that we did with the decimal system. We can say this consists of 128, no 64s, no 32s, has 116 in it, 1 8, 1 4, no 2s, but it has 1 1. So keep in mind, we did the same thing. So we had our place values drawn out, we had our number, now we broke it down, and we're going to take 128 plus 16 plus 8 plus 4 and 1 to get 157. So now we have applied the same principle. So all you have to remember is the only thing that changes is the base of it, which is a base 10 or a base 2 in a binary. So these are the place values that changes, and again that could go out. So you break it down in the place value, write your number underneath, and break it down into individual place values. So that's how you convert it. If I was just to sit down, and how would I count it if I just sat down and count? Because in decimal system, we all know I could just sit down and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all day long and never reach an end. So how would I do that in a binary system? So I was trying to figure this out, and I recognized a pattern. All we have to remember are the first 4 numbers in binary numbers, which is 0, 1, 10, and 11. This, if we can just remember this pattern, 0, 1, 10, 11, 0, 1, 10, 11, 0, 1, 10, 11, this ends all of our numbers from here to infinity. So we start with a 0, or we end with a 0, we end with a 1, we end with a 10, we end up with 11. Start back up. This happens to be the first 4 numbers in binary, 0, 1, 2, and 3. So, to carry this on, and when you get to the end, what you're trying to do is you're trying to get as many 1s in here as possible, because remember, your 1 in the binary system is your greatest single value. So once you reach an end, getting as much as you can, you put a 1 in front of it and replace these 1s with 0s. And if you notice, if I did that, put a 1 in front of it and replace these with 0s, this number is also going back to the beginning of the pattern. Now I move on to this 1. I want to end it with a 1 now. So it would be 1, 0, 1. So I ended up with a 1. Next would be 10, 1, 1, 0. Next would be 11, 1, 1, 1. Now we get back to this situation up here, right here. Just more 1s here. We've got as many 1s as we can for these 3 place values. So we want to move up to the next place value and replace these with 0s. And now we move back to 1. So 1, 0, 0, 1. Got that 1, so we want to put another 1 here and replace that with 0. You can think of it as that way, or you can think of it as following the next pattern, which is 10. So 1, 0, 1, 0. Next value would be, the next pattern would be 2 1s, so it would be 1, 0, 1, 1. And let me make sure you can still see this. Sorry, you couldn't see that last part, and the pattern keeps on continuing. So let's keep in mind these first 4 numbers, 0, 1, 10, 11. If we can remember that, we can count in binary all day long. So let's continue. If you don't need to continue, then you can shut the video off, but just for practice, we have these 1s filled up, so we need to move another place value up and replace these with zeros. So to do that, I'll write it up here. We move a place value up and replace it with zeros. And we're also ending with our next in the pattern. So our next in the pattern is 1. So we want to end with a 1. 1, 1, 0, 1. Continuing, next in the pattern is 10. So 1, 1, 1, 0. Next in the pattern is 11. 1, 1, 1, 1. You filled these up, so move up a place value, replace the ones with 0. So this is the basic concept of how this works. So if you need any help with this, just email us. Our email is on our YouTube channel, or you can, I'll just say it, it's einsteinthemodern@gmail.com. So if you have any questions, please email us, because we want this to make sense. It can be kind of confusing at first, but I think once you get the basic idea of this pattern and counting and how the place values change and converting, I think you'll do great with it. So if you have any questions, email us, and check out our podcast on our website, and check out some other videos. So we'll see you guys later. Thanks.